All right, here is a projectile problem from the projectile motion practice problems. I think if I'm looking, this is like on the third page. So it's labeled number 1, 2. Well, the parts are labeled number 1 and 2. Anyways, let's do this problem. So we have a projectile fired from a gun. It has an initial vertical and horizontal component of velocity, and you're given those. They're 40 meters per second and 30 meters per second. And we're assuming two significant figures. So the first question is determine the initial speed of the projectile. So I've already drawn a coordinate system. So all that remains is to draw the vector for velocity. So we're given the two components. The horizontal component is 30 meters per second. So we can, let me fix that. We can draw that distance in red here on the axis. So we go to the right 30 meters per second. And we can go upwards 40. That's the vertical component of the velocity. So if I label these, this is 30 meters per second and this is 40 meters per second. Remember, we're assuming two significant figures for these. The resulting vector is that vector right there. So let's label that V. We can write V in component form with x component 30 meters per second and y component being 40 meters per second. So the first question is determine the initial speed of the projectile. Remember, speed is the magnitude of velocity. So we can find the magnitude just from Pythagoras' theorem. So the speed is the square root of 30 squared plus 40 squared. And of course, this is, well, if you don't know, you can plug it in your calculator. You get 50 meters per second. So that's question number 1. Question 2, what angle is the projectile fired, measured with respect to the horizontal? So that is this angle right in there. So let's find 30. We're given the y component and the x component, so we know that tan of theta is the opposite side, 40 over 30. So we can solve for theta. This is just the tan inverse of 40 over 30. And remember, when you do this, keep your calculator in, well, you could keep in degrees. So your answer is in degrees. If it's in radians, your answer will be in radians. So my calculator was in degrees, and I calculated this angle to be 42.9. Well, I wrote 44. Let me backtrack a bit. 42.96 degrees. And to two significant figures, that's 43 degrees. All right, that's question number 2. Question number 3, approximately how long does it take the projectile to reach its highest point? At its highest point, what do we know? We know that it's, well, first of all, we know we can say what the motion is of this projectile in the x and y direction. In the x direction, we have motion with constant velocity. In the y direction, we have motion with constant acceleration, and our acceleration, is downwards. And its magnitude is obviously just the acceleration due to gravity. So what's happening in the y direction is that the bullet is slowing down and coming to a stop in the y direction. Its x velocity is going to remain the same. So at its highest point, the y component of the velocity at its highest point is going to be 0 meters per second. It's going to come to a stop, and then it's going to fall again. And this is assuming our y acceleration is minus 9.8 meters per second squared. So what we want to do is figure out how long it takes for the velocity to go to 0. We can use this equation here, that the velocity at the highest point in the y direction is equal to the initial velocity in the y direction plus our acceleration in the y direction times delta t. We can solve for delta t. Well, first of all, the left-hand side of this equation is 0. We know that at its highest point, the velocity should be 0. So we can then solve for delta t. Delta t is just minus the initial y component of the velocity divided by our acceleration. So this, plugging in some numbers, we have minus 40 meters per second divided by negative 9.8 meters per second squared. And the result you should get, I believe, is 4.08. The units, if we look, meters are going to cancel. This second is going to cancel with one of those, and we're going to be left with seconds. Again, this should be to 2 sig figs, so we can round this to 4.1 seconds. All right, let's go to question 4. What is the maximum height reached by the projectile? Okay, well, again, in the vertical direction, we have motion with constant acceleration. So its highest y position we can determine from the following equation. Its initial the initial y component, which is 0, plus the initial y component of the velocity times delta t, plus 1/2 times the acceleration in the y direction times delta t squared. Okay, so initially this gun started at the ground, and our initial velocity in the y direction was 40 meters per second, and our time we just calculated. You know what, I'm going to use 3 sig figs here because I want my answer to be as accurate as possible. So that's the time plus 1/2 9.8 meters per second squared. There should be a negative there, times 4.808 seconds squared. All right, so just again plugging all those numbers in your calculator, I got an answer of 244.7. Your answer might vary slightly depending on how you rounded. That should be in meters. And to 2 significant figures, this is just 240 meters. There you go.